Hi, my name is Solomon and I'm the robotics software engineer here at Robotics. And today I will talk to you about one of our newer products, the U-Factory xArm. The xArm is made from carbon fiber, so it's pretty lightweight. It's got sub-millimeter accuracy, can have a payload capacity of around 3 to 5 kilograms, and about 700 millimeters of reach. It's also really low cost relative to other industrial arms, which can cost up to a few $100,000. It also comes with an xArm Studio, which is a graphical user interface that allows you to program the arm without using code. And it also has open source Python, C++, and ROS packages. Despite the xArm developers already creating their own ROS packages, I was tasked with creating our own version of those ROS packages. And there's really three reasons for that. One is to test IROS. So IROS is the Interrobotics Research Robotics Open Standard. It's a modular way to structure code which should work with any robotic platform. So we've already developed using the IROS structure for our Dynamixel-based robotic arms. So by integrating another robotic arm, we'd be able to test to make sure that it would work as well. And it did. Another reason to develop our own ROS packages was to make it more modular. For example, the xArm developers created 6 types of Move It packages. There are 2 types for each arm. There's one with a gripper and one without a gripper. That's a lot of packages to maintain, so instead I took all that and condensed it into one Move It package with a lot of configurable parameters. Another reason to integrate it into our structure is because once you know how to work with one of our robot platforms using the IROS structure, you know how to work with any of them. As far as demos go, with our ROS packages, you can play around in RViz, you can simulate in Gazebo, play around in Move It. We also have some Move It interface demos, both in C++ and in Python, which allow you to pose the arm using a graphical user interface. You can also control the arm using a joystick or code just in Python and move the robot the way you want in fewer than 10 lines of code.